A question like this tends to come up every summer, and students find it very challenging. Let's make sure that you feel confident this summer. Part A says that we need to express what we're given here in this form. This is called harmonic form or alternate form, where k is positive and alpha is between 0 and 90 degrees. Note this question is in degrees. Make sure your calculator is in degrees mode. It says state the value of k and give the value of alpha in degrees to 2 decimal places. So you may be able to find a shortcut to answer a question like this. It's only 3 marks, but if you didn't know where to start, this is how you can work it out from first principles. So first of all, when it says express this in this form, it just means put this equal to this. Next, you can find a formula that's very similar to this, the addition rule for cosine, in the formula book. It just involves a's and b's. You can turn them into theta and alpha and write this. Next, we can expand the brackets here, multiply k by this and k by this. And I've just reordered a few terms here. What do we do next? Well, if this is going to equal this for any value of theta, then it must be that the coefficient of cosine theta on each side must be equal to one another. And similarly, it must be that the coefficient of sine theta must also be equal to one another. Since these both have these minus signs here, we can just say that this equals this. So that gives us 2 equations. The first one is this, and the second one is this. Remember what we're trying to do. We're trying to work out what does k equal and what does alpha equal. We can start by dividing the 2 equations. If we divide equation 2 by equation 1, well, on the left-hand side, we'd be dividing 480 by 140, and on the right-hand side, we'd be dividing k sine alpha by k cos alpha. Notice that the k's would cancel out, and what we're left with is sine over cos, and you should know that sine over cos is the same as tan. So we can apply arctan to both sides to work out what the angle alpha is, put that into our calculator, make sure we're in degrees mode, and make sure we round to 2 decimal places, as it says in the question here. We should get 73.74. Next, if we want to work out the exact value of k, we should square and add the 2 equations that we had up here. So square 1 and square 2, make sure we square everything, then add them together. So we've got 140 squared, that would be the same as k squared cos squared, and then we've got 480 squared equals k squared sine squared, and we're just adding those 2 things together. Why would I do that? Well, can you see that on the right hand side these 2 things have a k squared in common, so we can factor out k squared. And what have we got inside the bracket? Well, you should recognise that cos squared plus sine squared you should know is 1, so this just becomes k squared times 1, which is just k squared. Next, to get rid of the square, we take a square root, noticing that we don't need plus or minus signs here because we know that k is only positive. If you do the number crunching, you end up with k is 500. So we can put k is 500 back into here, and alpha is 73.74 into here, and we'll end up with the answer. Let's look at part B. It says a scientist studies the number of rabbits and the number of foxes in a wood for 1 year. The number of rabbits R is modelled by this equation, where t months is the time after the start of the year, and A is a constant. Given that, during the year, the maximum number of rabbits is 1,500, find a complete equation for this model. Well, first of all, I'm just going to note the answer that we came up with in part A. We found in part A that this was equal to this. Just another way of writing it. Why is that important to this question? Well, you should notice that what we've got here looks very similar to part of this equation. Notice it's not the whole equation because we've got an a plus here, and it's not quite the same because we've got 30t here and here, whereas here we've got theta. So that's telling me there's another way of writing r. It's a plus something that's very similar to what we had in part A, this part, just changing the theta into 30t. So we've rewritten r in another way. Now, it says the maximum number of rabbits in the wood was 1,500. Now, of course, as t changes, cosine of this will change as well. But when would it be at a maximum? What's the maximum value of cosine of something? Well, the maximum value of cosine, if you think about the graph, is 1. So the maximum value of this part is going to equal 1. That's going to be when the population of rabbits will be at its maximum. So we've got the maximum population we were told in the question was 1,500, and that must be the same as A plus 500. So therefore A is 1,000. So we can substitute that back into this equation that we had here. And there we have the complete equation for the model. Part 2. It says, hence, write down the minimum number of rabbits in the woods during the year according to the model. When would we have a minimum for R? Well, as t changes, cosine is going to change. And that will change the value of R. We really want this cosine to be at a minimum. What's the minimum value of cosine? Think about the cosine graph. The minimum is -1. So R is going to take on its minimum when this part equals -1. So we just substitute that in. And 1,000 take away 500 gives us the minimum of 500. Part C. The actual number of rabbits in the wood is at its minimum value in the middle of April. Use this information to comment on the model for the number of rabbits. So we're commenting on the model. We need to say, is it a good model? Is it a valid model? Or is there something that's wrong with the model that could be improved? Let's think about what it's saying here, the middle of April. And let's refer to what it said here. T was measured in months after the start of the year. So at the very start of the year, at the start of January, T would be 0. At the start of February, T would be 1. Start of March, T equals 2. The start of April would be T equals 3. And the start of May would be T equals 4. But we want the middle of April. If T equals 3 is the start of April and T equals 4 is the start of May, the middle of April would be T equals 3.5, halfway between 3 and 4. So we can return to our equation for the number of rabbits R that we had here and just replace the T with 3.5. And we end up with 500.1. And that's very, very close to the answer that we had in part B. We came up with the minimum being exactly 500. So it's so close we can conclude that the model is reliable. Make sure you write down that conclusion to score the final mark. Part D. The number of foxes, F, in the wood during the same year is modelled by this equation. The number of foxes is at its minimum value after capital T months. Find, according to the models, the number of rabbits in the wood at this time T months. So we've got the equation for F given us to in the question here. When are we going to have the number of foxes being at a minimum? Well, that would be when this part of the equation is at its minimum value. What's the minimum of sine? Think about the sine graph. The minimum of sine is -1. So it would be when this part equals -1. I've just replaced little t by capital T because that's the notation they're using in the question. So we can solve this equation. Let me just write that equation down here. Let's apply arc sine to both sides to get rid of the sine. And we'll get in degrees, remember working in degrees, 270. If you subtract 70, we get 30t equals 200. And divide by 30, we get capital T is 20 over 3. Remember, the question was asking us about the number of rabbits here in the wood. So let's return to that equation for the number of rabbits that we had. And we'll replace the t with this value that we've come up with, 20 over 3. So replacing that in the equation, we get this from the calculator. And it could be argued that we can't have 0.6 of a rabbit, so you could argue it's 1,032. But the mark scheme also allows you to round up to 1,033. Either of those two answers gets you the final mark.